Hi everyone, I am Amit Dharnia, Assistant Professor in Department of Mechanical Engineering of Arya College of Engineering and IT, Kukas, Jaipur. Today we will discuss about the different type of gearboxes used in the vehicle, as it is the unit of transmission system of a vehicle. So let's we start. Gearbox in automobiles. What are the purpose of a gearbox? Gearbox provides speed and torque conversion because of the limitation of internal combustion engines, and it also facilitates change of direction of output shaft for reversing. Automotive gearbox are used to reduce load on the engine by manipulating torque and speed. They have the option to select one of the several different gear ratios. Once the engine has reached a number of revolutions per minute, it is advisable to increase the gear to reduce the engine RPM, to reduce wear on the engine and allow more control and greater speed, better accelerations and better fuel economy. Most of the gearboxes are used to increase torque and reduce the speed of a output shaft. This provides a mechanical advantage, and automotive gearbox also have the provision to do the opposite, like provide an increase in output shaft speed with a reductions of torque, like overdrive. And the most of basic type of gear is a spur gear, and it has straight cut teeth where the teeth are cut parallel to the axis of the gear. And in the wider gear, and those that are cut for smoother meshing are cut with the teeth at an angle. These are called the helical gears. So these are the basic gear which we can use in the gearbox. Because of the angle of the cut, helical gear teeth have a much more gradual engagement with each other, and they operate more smoothly and quietly than the spur gears. Helical gears can transmit more torque because at any time more number of teeth are in mesh. Gearbox for car and motorbikes almost always use helical gears. However, helical gears also exert undesirable axial thrust. To prevent axial thrust, double helical gears are used, which can cancel out the thrust. Double helical gears are called herringbone gears. This is a typical example of gear ratios of 5-speed manual gearbox. Like in the first gears, there is a speed gear ratio of 3.166 ratio 1. At the RPM of the gear shaft is 947. In the second gear, ratio is 1.882 ratio 1. In third gear, 1.296 ratio 1. In fourth, 0.972 ratio 1. And in fifth, 0.7382 ratio 1. When the engine speed RPM at 3000 RPM and the gear output RPMs are according to the gear ratio are mentioned in the table. So there are many types of gearbox we used in our automobile transmission system, like sliding mesh gearbox, constant mesh gearbox, synchro mesh gearbox, transaxial gearbox, sequential gearbox, and automatic gearbox. So sliding mesh gearbox, as we can see that in its constructional details, it has a main driver gear, a counter shaft, then a main shaft. On the main shaft there are 3 gears, first, second and third, and a top speed gear also mounted on the main shaft, which is engaged with a dog clutch. Normally 3 forward and 1 reverse gear ratios per gear are used. Gear wheels on the main shaft engage with gear wheels on the lay shaft counter shaft by sliding themselves, and they are not used in automobiles now. This is the simply sliding mesh gearbox in which a clutch shaft is always attached with the output of the clutch, and there is a gear number 1 is mounted on the clutch shaft, which rotates always when the clutch shaft rotates, and which is matched with the gear number 2 on the counter shaft or lay shaft, and on which on the lay shaft there are gear number 3, 5th and 7th, and also there is an ideal gear, and a reverse gear number 8 is also mounted on the counter shaft, and they on the main shaft which is splined, on which gear number 4 and 6 are attached. So for the required output we have to just slide the gear which is splined on the main shaft and matched with the gears which are mounted on the counter shaft. Like in this first gear we matched gear number 6 with the gear number 5 to obtain the required gear ratio, and the rest of the gear number like 4, 6, 4 are unmatched, and the gears are slided with a gear lever. And in the second gear we can see that gear number 4 is matched with gear number 3 to obtain a required output. When we match the gears with the gear on the counter shaft gears, then the splined main shaft rotates and we can receive our output on a required gear ratio on the main shaft, and the main shaft is attached with the propeller shaft or the differential to rotate the wheels. And in the third gear we directly matched the main shaft with the clutch shaft to obtain the output, and for the reverse gear we matched the gear number 6 with the gear number 8, which is a reversible gear, and mounted on the counter shaft by the help of a ideal gear which rotates the main shaft in the reversible direction, and we obtain the reversible motion of the shaft. Constant mesh gearbox. In this all the gears are always in mesh. Gears on the counter shaft are fixed to it, and gears on the main shaft are free to rotate. Dog clutch can slide on the main shaft and rotate with it. Dog clutch engage with the gears on the main shaft to obtain desired speed, and it has advantage over the sliding mesh gearbox like helical and herringbone gear can be used in these gearbox, and therefore constant mesh gearbox are quieter since the gears are engaged by dog clutches. If any damage occurs while engaging the gears, the dog unit members get damaged and not the gear wheels. This is the general construction of the constant mesh gearbox. It is likely the sliding mesh gearbox, but the difference is that all the gears on the main shaft, splined main shaft and lay shaft are always matched with each other, but the gears on the splined main shafts are not directly attached with the spline of the main shaft. They having a bearing on it by which they can only freely rotate on the spline shaft, and there is a sliding dog clutch which has the internal spline and attached with the spline main shaft. When the dog clutch rotates, the spline main shaft also rotates. So just by sliding the dog clutch and attached with the different gears on the spline main shaft, we can obtain the different gear ratios like For the first gear or for the lower gear, we have to just spline our dog clutch and attach with the lower gear, then we can obtain our output. And for the second gear, we have to spline our dog clutch, which is between the clutch gearbox and the second gearbox, have to match with the second gear to obtain the second gear ratio. And for the directly gear ratio, we have to top gear ratio, we have to just slide the dog clutch with the clutch gearbox and obtain the required gear ratios. And for the reverse of the spline, we have to just slide our second dog clutch and mesh with the reverse gear, by which we can obtain the reversible gear ratios. So this is a constant mesh gearbox and it is easy to operate. Next is sliding synchro mesh gearbox. Sliding synchronizing units are provided to equalize the speed of the gear and dog before meshing. The device works like a friction clutch, which is equal speed ensure smooth meshing, normally not used in first and reverse gear. And its working is just like that. Output shaft is always rotating, connecting to the wheels, where the lay shaft is connected to the engine, but it rotates freely when the clutch is disengaged. Because the gear are meshed all the time, the synchronize brings the lay shaft to the right speed for the dog gear to mesh, and the lay shaft is now rotating at a different speeds to the engine. Now the clutch gradually equalize the speed of the engine, and lay shaft either brings the engine to the same speed as the lay shaft or vice versa, depending on the engine torque and vehicle speed. This is generally constructions of the synchro mesh gearbox, in which spring loaded balls holds the collar together and pressure on the gear lever cause tooth outer ring to slide into engagement and the power may transmitted. This is the constructional detail of the synchro mesh gearbox. Thank you. And the rest of the gearbox, like automatic transactions, we will discuss in another lecture. Thank you.